So we've just finished up putting Wall-E together, fully going through and testing all of the arm mechanisms, the new neck mechanism. So I'm at the point now where I'm ready to start taking them apart and look at painting the arms and the neck. So I figured it was a good time to go through taking them apart and showing you guys, some of the modularity that we built into Wall-E throughout the design and the build that David and I have been working on. So let's get started and start taking things apart. We can begin by the front is just held on with magnets. I mean, we haven't looked at going in and designing a mechanism that can actually lower and open. We thought about doing that and, taking and putting a false facade on the inside. You could open up and you could have a picture of a trash cube in there. I mean, might be pretty cool. So if someone wants to take that on, that would be awesome. So again, it's held on with magnets there. This section's also held on with magnets, but it's wired up now, so we won't take it out. And then the back is also held on with magnets, and it just comes apart so that it's easily accessible. Go ahead and show you some of the inside. And some of the things we'll have to take apart. So one of the things that's always important, always make sure you're fully disconnected from your power. So everything is off here. One of the things we've done is made the batteries modular. So now we can pull those out and charge those independently outside the droid, or if we have some more built, then we can just hot swap those out. Go right back to making people smile. And you can see all three of those are fairly easy to remove. Try to see if I can light up a little bit on the inside. So you can see a couple of the things we have going on in here. Tried to make it as clean as possible, but there's so much going on in this thing. Trying to find a place to put everything's been difficult. So you can see one of the connectors here for the arm, and I'll undo one of those in a sec and show you how that comes out. So let's see if we can see that. So I've got those Velcroed up there, keep them up out of the way, and then that just disconnects with a locking connector that I have there. So we'll put the camera back up. Then once that's disconnected from the inside, the arm just basically slides directly out. You can see we chose to use hex shaft here for a couple of reasons. It locks in really nicely, and then you can actually do some adjustments on the inside, and I'll actually show you some of that once we get the body off. And again, there's a close-up of one of the connectors. I like using this Tessa tape. Justin introduced me to this stuff, Justin Motter, and you can see it puts more pressure out here on the outside of the wire instead of putting all the pressure on that connector. That connector becomes a lot stiffer, so you don't end up tearing the cable up as you're trying to change these in and out. The other arm comes off just as easy. Just undo the Velcro. And arm slides right up. The neck and the head mechanism can also be separated. It's fairly easy to do. I just take the sleeve off, and then it has two connectors, one for power and then one for signals. Show you the back side of that. You can see there's the power wire, plugs in there, and then signal wires plug in there. And I try to offset those to keep the bulk down inside the cabling, and then I also change the ends. So this will have a male and this will have a female, so you don't end up plugging in the wrong cables to the wrong plugs, causing sparks Not good. Second side comes off just as easy. Then once both of those are loose, there's a set screw here. And you'll take that loose, and then the head pops directly off. Another reason for wanting that modularity is the ability that once this head is off and it's down at its lowest position, I can then just drive Wall-E right up into the vehicle and not have to take anything else apart. Makes transport really easy. To get the neck off, it's held on with 4 screws that hold it on to the welded frame. And then there are 2 cables that have to be disconnected. And once those are loose, you can take the actuator loose. It has 1 bolt going through it. Once that's loose, you can take the neck directly out. You can see there are the cable connections, and then that connects to the actuator. You can see the up and down movement there. Make sure I get that in the camera. Once those are disconnected, and all the wires are out of the way, the body will just lift directly off. So now we can get a little bit closer look at what we have on the inside. We'll take a closer look at the front panel. You can see an actuator here that is controlling the body tilt. This is assisted with springs in the front and in the back. It pulls the springs down and compresses this system that actually gives him the look of actually leaning down and up. The spring system was originally designed by Mike Cena and Michael McMaster. And that acted as a free-floating system to kind of give Wall-E some free animation while he was driving. It looks like he's wobbling around or just kind of moving his body back and forth, going over bumps and stuff. So it's really cool. It still offers that same look with this spring system, which works out really well. I've got the control system here, which is an Arduino Mega with a breakout board on top. That I've connected the sound card on. So everything is triggered through an RC remote that triggers all the sounds and then triggers all the motions through a Maestro servo controller. Stefan Balou did all the programming and writing of the code for this. So it's worked out really well, and a huge thanks for him for writing all of that code. As far as controlling the actuators, I've got these servo controllers. They basically turn a motor into a servo that already has a potentiometer involved, or you can add a potentiometer to a motor, and then you can use this to make it work like a servo. Those were pointed out to me by Chris Lee, and he used them on one of the iterations of his C3PO. You can see the power system distribution here. I've chose to go this route just for simplicity during the at the current time, and it's just that I can limit the amount of current that these draw by limiting the changing the fuse here. So if I put like a 2 to 3 amp fuse and the arm comes down and someone gets their arm in the way, and then the arm tries to keep going, this actuator is going to go up to around 6 to 7 amps. So if I put a 2 to 2.5 or 3 or so amp fuse in here, the fuse is going to blow before someone gets their arm mashed harder than it needs to be. Don't want anybody getting hurt by these things. And these actuators are super strong. These are the 35-pound that I've got in the arm. I've currently got the 50-pound in front for the body tilt, but I'm going to change that out to the 35. Then you can also see we've got the actuator here that controls the neck mechanism up and down. Here you can see the arm raise up and down. This is designed by David Ferreira, along with the motion arms and the neck mechanism. So really great friend and a great designer all around. Good guy to have working on this project, and it's really been really enjoyable. You can also see that you can take it a little bit farther by taking the tracks off. So each track comes off independently, which would then leave just the core system alone by itself. So it makes everything really modular for travel if you needed to take them apart and package everything up and send by plane or something like that. So I haven't got to that point, but you never know. So that's about it. I think one of the other things I meant to mention, we can mention Mark as far as designing the drive system, the tracks, and everything for that. Was based off of Mike Cena's original design for the all-metal track drive system. So I don't think I've left anything out as far as what I'm using to control him. If you guys have any more questions, need any more answers, just let me know. Until next time.